Hi everyone, in this video we're going to go through 16C, determining normal probabilities. So in 16B we went through the 68, 95, 99.7% rule, and that's for 1, 2 and 3 standard deviations either side of the mean, but we can actually work out the other percentages. So we don't always have to look at just, 1, 2 and 3 standard deviations. You can be any standard deviation from the mean. So this is what we're basically doing in 16C. Now, to do this, we just use the calculator. All right, so there's a lot of calculator work for this section. In your notes are the instructions, but I'll also go through how to do it in your calculator as well. Okay, so with example 4, suppose that Z is a standard normal random variable. So remember, whenever you see standard normal distribution or random variable, your mean and your standard deviation are always the same. Okay, so let me just get my little highlighter. Okay, so your mean will always be 0 and your standard deviation will be 1. So that's only for standard normal distribution. Okay, so if you see the word standard in front of normal, just means you've got a mean of 0 and a standard deviation of 1. Okay, so for question A, we need to find the probability of the variable, standard normal random variable, is between -1 and 2.5. So on your calculator, all right, so you've got these steps here, so let's go through them. Let me just get my calculator up, and I'll leave that screen there as well. Just move that so we can also see it. Okay, so we go into main. Calculator. Oh, we're already in main. Sorry. Interactive. Don't know what I was expecting to happen. Distribution and continuous. And this time we are going to normal CDF. Okay, and so our lower bound is -1. Our upper bound is 2.5. All right, and because it's normal, it's just already got it set as standard deviation is 1 and your mean of 0. All right, and there's your value there. So 0.835, blah, blah, blah. So usually we do that to 4 decimal places unless specified otherwise. All right, the other way you can do it, and this way we can actually see the graph. So sometimes it's a good idea to graph it. So you can see there's your normal distribution. So this time we're going into statistics. So we're going to menu. Statistics is in the other screen. Okay, and calc, distribution, and select normal CD. All right, so it's PD. Let's just change that to normal CD. Oh, why isn't things working today? All right, let's just restart the calculator. Get the notes back up. All right, so statistics, calc, distribution, normal CD. Okay, tap next. And your lower bound for this one was -1, up bound is 2.5, and you can see that on the screen. And your mean and your standard deviation are just 1 and 0. So they're not always going to be 1 and 0, but we're just looking at the standard normal distribution for now. But in a sec, we'll go through questions where the mean and the standard deviation are not standard. So that just means in the question, it will tell you what your mean and your standard deviation are. All right, so there's your probability. Now, if we want to see the graph, and you can just see it up the top there. All right, so there's our graph there. So clearly a normal distribution. Now, if you have to graph it, the graph is always the same. Your normal distribution shape is always the same. It's just your mean and your standard deviations will change. So for a standard normal distribution, it would always be 0 for your mean and 1 for your standard deviations. But if it was just a normal distribution, but if it wasn't standardized, you would just put your mean in the middle and your standard deviation. So we'll do a few questions like that in a sec. And there's example 2. So the second one, I'm not going to go through that. All right. What you can also find, so we were given values, lower and upper limit, so our 2 standard deviations and finding the probability. But what about this time if we were given the probability and we had to find what the standard deviation was? Okay, so suppose X is normally distributed with a mean of 100 and a standard deviation of 6. Find K such that the probability of X is less than or equal to K is 0.95. All right, it's just started to rain. 10 minutes ago, I said to my son, go ride to the shops and get some lunch. And then luckily I looked at the rain radar because I said, no, it's going to rain in like 15 minutes and it's just started raining. Anyway, you don't need to know that. So using the Casio class pad. All right, so let's go back to main. All right, interactive, distribution, inverse, inverse normal CDF. Okay, so tail setting, we want it at the left. Okay, so we're looking on the left side, so less than K. All right, so that's what we got in the question. Enter the probability as 0.95. And this time our mean, so first of all, they got the standard deviation. So your standard deviation is 6 and your mean is 100. Just make sure you get them around the right way. Although I don't think, you're going to cooperate, calculator? There we go. All right. It probably, oh no, it would still work. You could have a mean of 6 and a standard deviation of 100, but that would be really weird. Okay, so then we get 109.89869, blah, blah, blah. So what that is basically telling us is the standard deviation. Oh, not the standard deviation. Standard deviation is 6, the value of K that gives us an area of 0.95 or a probability of 0.95. All right, so just important here, and they've rewritten it here. So the tail setting is left to indicate that we set the value K such that 95% of the area lies to the left of K. All right, so less than K. So if it was greater than K, you would do right. All right, second method when we've got our graph. So let's just get that back, calculator back up. Okay, so let's go back to our statistics menu. Statistics. Okay, calc, inverse distribution. Okay, so we want to do inverse normal CD, so it's already there. Tap next. Okay, so your tail setting we want as left. All right, your probability is 0.95. And this time remember our standard deviation is 6 and our mean is 100. All right, so there you can also get the value, and if you want to graph it, so you can see that shaded area is 0.95 and the 109.87 is this value. You can't see it because my arrow isn't working, but it should be flashing there. All right, now just below that, the symmetry properties, because the normal distribution is symmetrical. Okay, you do have symmetry properties. So the probability that Z is greater than A, so this part here, whoops, I'm highlighting yellow with yellow. This part here is the same as 1 minus Z is less than A. Okay, so just those symmetry properties. So that area there is the same as this area here. Okay, because normal distribution is symmetrical. All right, let's jump in and do some questions. So we're going to do all these on the calculator. So you don't need to do any of these by hand. All right, I'm not going to do all of them. I'm going to do question 1. I'm not doing all the parts of the questions because once you got the hang of it, you'll be fine. So suppose Z is a standard normal distribution. Find the following probabilities. So I do prefer to work with the graph, and you also have to, oh no, this one you don't have to graph. Oh yes, you do. Drawing an appropriate diagram. There we go. So let's just go back. Okay, so the probability that Z is less than 2, so we're going to the left. Whoops, no, wrong. Oh gosh, I need to get out of this, sorry, wrong thing. All right, calc, distribution, and normal CD. All right, so I just had to restart my calculator, sorry. So for 1A, we've got Z is less than 2. So think about your upper limit and your lower limit. And this is continuous, so we don't have to worry about whether it's included or not included. So your lower limit is negative infinity. So on our keyboard, we can get negative infinity up. Let's just find, where are you, infinity? All right, so negative infinity. And our upper limit is 2. And it's a standard, so we're just doing that. Can I get rid of my keyboard? All right, so we've got 0.9772. All right, for the next, I mean, they're pretty straightforward. The rest of you do the same thing. All right, the only thing that's changing is 2.5. B and C are the same, so it doesn't matter if you're less than or equal to, and 2.53. So each time you're looking at a greater area. So let's just do D. So go back to the calculator. So go back. So your upper limit is 2.53. So you can see our area has increased, or our probability has increased, so 99.43. Sorry, 9943. All right, so with question 2, it's exactly the same thing, but this time we've got greater than. So let's just go back to our calculator. All right, so we'll go back. So this time our lower limit, if we're just doing A, is -2. And then our upper limit is infinity. So we'll get the keyboard, infinity. And there's your probability. So 0.9772. And it does say draw an appropriate diagram. So if I was to draw a diagram for this one, all right, so there's my mean of 0, so -1, -2, -3. And then 1, 2, 3. And I'm using those values because my mean and my standard deviation are standard. All right, so we're at -2. So this whole area is 0.9772. Now, when we go back to question A, you can see you've got the same area. So that's what the symmetry properties mean. All right, so if I go from 0, 1, 2, 3, we'll just finish it off. 1, 2, 3. And this time we've got Z is less than 2. All right, so this area here. So you can kind of see that it's symmetrical. The section we don't want, which is this bit, it's the same. It's just on the other end. Okay, let's move on. So question 4, suppose Z is a standard normal random variable. Find the following probabilities, drawing an appropriate diagram. So this time we've got intervals. So for the first one, we're going between 2 and 3. And you'll notice Z is being used because it's standard normal. What am I looking for on my calculator? Okay, so we'll go back. So this time the lower limit is 2 and the upper limit is 3. We're still dealing with the standard normal. All right, so there you've got it, 0.0214. If you were to draw that, all right, so if we were to draw that, let's quickly, so 0, 1, 2, 3, and then -1, -2, -3. We're basically finding the area between 2 and 3. Yeah, so you can kind of see it's quite small, just that little section there. I can't remember what the answer was, so I might just write that down. So 2 and 4. All right, so quite a small area there, which we would expect. All right, now question 5 is slightly different. So what we're doing here, and like we did in the second example, all right, so remember when we did this second question, we were looking for K. So questions 5 to 9, we're using the same theory. So we've got to go to inverse normal. So let's go out of there. All right, so calc, inverse distribution and inverse normal, beautiful. All right, so the first one we've got Z is less than C, so we want left. And the probability is 0.9. And it's still standard, so we're sticking with 1 and 0. All right, so there you've got 1.282. I'll do 4 decimal places, 2860. All right, if we were to do question 8, all right, so the 6 and 7 are the same, you're just changing your probabilities. So question 8, this time we're going right, okay, because we want to be greater than C, so we're looking on the right side of C. So that's 0.95. And you got it's standard, so it's 1 and 0. All right, so there we've got it. If you need to look at it graphically, just quickly press the graph and you can see it. And you kind of say, well, have I done it correctly? So we want Z is greater than C is 0.95. So it's kind of makes sense that C is down here. So that's 1.6449. -1.49. All right, so if you're drawing your diagram, let's just do 9 because I've got space for 9. We'll go back. So Z is greater than C, so we're doing right. Now, if you need to write down whether you're choosing left or right, it's probably a good idea to put that in your theory. This time our probability is 0.8, and it's still standard. All right, so there you can see it's -0.8416. All right, so if we were just drawing that normal distribution, same curve. All right, and because it's standard, we've got 0, 1, 2, 3 again, and -1, -2, -3, and 0.8416 is not quite before 0.1, so we're here. All right, so we're looking at this proportion here. Did I copy that down correctly? 0.8, okay, cool. Actually, no, I didn't do that right. Is that? No, that's a different graph. There we go. All right, so just reset your graph because that was the old graph and you can see you're just before 0.1, which makes sense. So that's what I was thinking, there was something wrong. All right, question 12. This time we've got a different value of the mean and the standard deviation. So it's no longer a standard normal distribution, but you do your working out the same way. So we did one of these before with the examples. Okay, so let's get out of there. All right, and we're going to now go back to distribution and, okay. We just want distribution, thank you, and normal CD. All right, so this time we're going from x is less than 110, so we're going to start with negative infinity. And our upper limit is 11. Now our standard deviation, don't get your standard deviation and your mean around the wrong way, because it's written mean first and then the standard deviation, but your calculator wants your standard deviation first and then your mean. So don't get them around the wrong way. All right, so we've got 0.9772, which is the same as those previous answers, weren't they? Okay, so if we were to actually do that, yeah, so you can see that's 2 standard deviations above the mean. So one standard deviation being 0.5, 2 standard deviations would be 1. So 11 is 2 standard deviations above the mean. All right, now question B is slightly different because we've got conditional probability now. Okay, so we've been okay up until this point. It's the first time we've hit conditional probability, but hopefully you're familiar with conditional probability. Okay, so my son's messaging me, asking me when work finishes so I can go get his lunch. All right, so we want the probability. So I'm looking at question B, the conditional probability. So I'm just going to write down the conditional probability formula. So the probability of x is less than 11 and x is less than 13 over the probability that x is less than 13. Now that's just substituting these values into the conditional probability formula. Now I don't think we've done conditional probability yet in normal, but normal is the same as conditional probability. Okay, so you should, not conditional, sorry, wrong C word, continuous random variables, sorry. So normal distribution or normal is the same as continuous. All right, so that is equal to the probability x is less than 11 and also has to be less than 13. So what do they have in common? X has to be less than 11 over the probability that x has to be less than 13. All right, so let's just do that on the calculator. Yeah, okay, I'm going to leave it there. I can keep it there. So x is less than 11. Let's do this one on the main screen. Okay, so we're going interactive distribution and continuous normal CDF. Okay, so our lower limit, so this time we're doing less than 11. So we want to do negative infinity to 11. And it's not standard, so our standard deviation is 0.5. And our mean is 10. All right, so I'm just going to leave that answer there. Oh, we already did that. I didn't even realize. Okay, continuous, null CDF. All right, so the lower limit for the next one, so we've got negative infinity. And then we're up. Upper limit is 13. All right, our standard deviation is 0.5 and our mean is 10. Please don't get them around the wrong way. It won't tell you. Okay, so, well, that's practically 1. It will never be 1 because normal distribution goes from negative infinity to infinity, but we can just copy that down. Don't do any rounding until the end, girls. There's enough decimal places there for me to do that. Don't have to work with exact values. All right, because 0.999999 is practically 1, it's the same as dividing by 1. So that's why we get the same, so 0.9772. And I might talk about, just the probability that x is less than 13. If you think about the normal distribution or this normal distribution for this question, our mean is 10 and our standard deviation is 0.5. So this is 10.5, this is 11, this is 11.5, then 12, then 12.5, and then 13. So you can kind of see why it would be close to 1, because we're basically looking at the whole area there. All right, so x is less than 13. 13 is right up there because our standard deviation is quite small, 0.5. All right, so how many standard deviations from the mean is that? So we've got 1, 2, 3, 4, 5, 6 standard deviations from the mean. So we know that 3 standard deviations from the mean is 99.7%. So that's why 13 or 6 standard deviations from the mean is pretty close to 100%. All right, let's move on to C and D. So for question C and D, we're doing inverse. All right, so quickly get that up. So I'm going to just do it from here. Okay, so this time we want less than, so the left, the probability is 0.95. And our standard deviation is 0.5. And our mean is 10. All right, so there you can see C is 10.82. I'm not going to write that down. All right, and then what am I doing? Inverse. All right, so this time we want less than K is 0.2. So we're going to use left again, 0.2. And then standard deviation is 0.5. And the mean is 10, and I don't know whether you can hear that, Sarah. Hopefully everything's okay. So 9.5792. And then what's the next one? C1 and C2 such that the probability of X is between C1 and C2. Oh, that's getting quite loud. Hopefully everything's okay. All right, now my knowledge of very loud, is of normal distribution, I'm getting distracted now, is that 0.95 is 2 standard deviations from the mean. Okay, so I know this without doing anything on my calculator. So our mean is 10. Oh, it stopped now. I hope everyone's okay. All right, so we're 0.5 standard deviations above, so 10.5 and 11, and then 2 standard deviations below, what is that, 9.5 and 9. So C1 and C2 are there. So C1 is 9 and C2 is 11. Now, I don't think you'll ever be asked to calculate those 2 values, okay, other than knowing 95%. All right, so if you see a question like that, it's highly likely going to be 0.95, and then you know it's 2 standard deviations either side of your mean. All right, girls, I think we have class very soon. So, yep, make sure you know how to do that on your calculator. It's extremely important that you remember normal is the same as continuous, so it doesn't matter whether you've got a less than or equal to sign. Remember the difference between normal and inverse normal, and also whether you're looking to the left of your value or the right of your value. And also make sure you can graph on your calculator as well. All right, girls, bye.